Dear listeners, a warm welcome from my side to the podcast of the FIB, the International Federation for Structural Concrete. My name is Nadine, I'm your host and one of the board members of the FIB Young Members Group. I'm very happy to hold this first episode of the new FIB podcast series on concrete sustainability. My guests are personalities from practice and research who have a strong relation to concrete sustainability in any kind, with a focus on ecologic sustainability, but social and economic aspects are not excluded. In this sense, I want to welcome my first guest, Professor Benjamin Kromoser. Benjamin Kromoser is the head of the Institute of Green Civil Engineering at the Institute of Natural Resources and Life Sciences in Vienna. He is a civil engineer and inventor with a close connection to craftsmanship. His research, teaching and practice is oriented towards the best possible use of natural resources in the construction sector. He covers a wide spectrum, including the automation and digitalization of constructive production processes, economic and ecologic optimization of structures, as well as the sustainability assessment of buildings, amongst others. He facilitates the use materials according to their properties and strives to minimize the environmental impact of buildings, considering the whole life cycle. I'm very glad to have you here and curious to have this interview with you now. We are currently sitting in your office at the University of Natural Resources and Life Sciences in Vienna, and I want to jump right into our conversation about concrete sustainability. So, in the first part, I want to go to your professional roots. So could you tell me about a time when you did your studies, your PhD? Where was it and how prominent was the consideration of sustainability back then?
Hello Nadine, thank you for the invitation to the talk today. I think it's a great topic and I'm curious about what we will talk within the next time. To the first question, basically I would say within my studies the topic of sustainability was included only to a minor extent. Maybe I want to give you a short overview about what I did in the past. Between 2007 and 2012, I did my studies at TU Vienna. I studied civil engineering and at the end, my master thesis was in concrete construction. And then I finished in 2012 and started a PhD in the group of Professor Johann Kollega and had the possibility to develop a new shell construction method. And I finished then in 2015. And there, I would say, there was the first contact with sustainability, because for me, not only the structural performance and the technical development was important for me, there also it was important to measure the environmental impact of the structure, because it was often an argument and we could not quantify it. And I think it's a common thing that people are arguing with being structures more sustainable, but they don't do a proof about that. And that was what I wanted to do within this. And then afterwards, in 2016, 2017, I got the possibility still at TU Vienna to play a major role in constructing a deer pass. It was the deer pass AM2 above the Go-Alm track. It's a newly built two-rail track in Carinthia in the south of Austria. And we really applied this construction method there for a bridge with a span of 36 meters. In 2018, I was appointed as professor at BOKU here, where I'm now, and where I had the possibility to build up a completely new group. So now about sustainability. Within my studies at TU Vienna, as I already said, got in touch with that only to a really minor extent. I remember that we calculated different resource streams and the own CO2 footprint of a person, but there was a major focus at transport. So I remember that there was a big impact when you fly with an airplane, but I didn't remember that the impact of the building industry is quite big. And I think at TU Vienna, it's a great university, and I received a really solid fundamental education in civil engineering, including statics, building construction, regarding the properties of materials and economics. But how sustainable these constructions are was definitely not in the focus.
Yeah. Thank you for this insight. I think I have the exact same experience. I also studied at the University of Technology in Vienna, and resource efficiency was only important when it came to economics. So we kind of had to keep the costs low, but we never actually looked at the environmental impact of a certain structure, of a certain material. And you also mentioned the PhD project, which was the concrete shell, which has already been realized. So what would you say were some challenging parts in that, more the design phase or the construction per se of the structure, or what would you answer to that?
As you said, my PhD project was a new shell construction method for concrete shells. And concrete shells are also, I would say, quite difficult in calculation, but you can do it in a really good way using finite element calculations programs. And so that was not the problem. The real challenge was to develop the new construction method, because a double curved formwork is quite complex. And so I spent quite a lot of time in developing these construction methods, mainly focusing on the bending behavior of hardened concrete, because I looked into different reinforcement materials, also at the influence of the concrete itself and the bending behavior. And it took me quite a lot of time also to investigate how we can inflate such structures, because there is a heavy weight, and although we have this weight of concrete, the pressure inside the pneumatic formwork was quite low. So I thought quite a lot about the regulation of the pressure, because it was that low, and there is not much about that in mechanical engineering. And so that was the most challenging thing, to really develop the construction method with all boundary conditions.
Mm-hmm. You said it had a span of around 35 to 40 meters, right? And how thin was the shell then actually?
Yeah, it's a good question. When you want to bend hardened concrete, it's always a connection between the thickness and the radius of curvature. And when you think about a really thin plate made of wood, for example, then you can bend it, and it's the same for concrete. And the first experiments we did, they were a bit smaller. They had a diameter of 13 meters, and then the second large-scale experiment had a dimension of approximately, I think, 11 to 18 meters. There we had a thickness of 50 millimeters. And then for the bridge, we scaled that up with factor 2, and we had a thickness for this big plate with 100 millimeters for the inflation process.
Yeah, very thin, such a wide span length. I saw a video of the construction process, which is published out there. I think we can also link it afterwards. I now want to move on, and for all our listeners, I want to quickly give some background to actually outline the significance of concrete-related emissions. Is it a thing or not? So there are a few numbers out there. I want to give you one. So for example, according to the Global Alliance for Buildings and Construction by the United Nations Environment Programme, the building industry is responsible for slightly above 35% of global CO2 emissions. And in this context, cement as the binder material of concrete is often stated to be the highest source of those CO2 emissions. So I think all these information can be quite overwhelming and quite paralyzing to a certain degree. Also for our listeners, maybe it was for me actually when I started my PhD. So maybe you can help us out here a little bit and tell me and the audience which levers do generally exist to reduce those emissions which are related to concrete structures, and how effective would they be?
Yeah, it's a good thing. Maybe to step in, concrete is nowadays often mentioned as the bad material. I wouldn't say it like that, because we have available different construction materials, and concrete is one of them. And every construction material has its own properties. And if you want to build a cellar, for example, or if you want to build things into the earth, then concrete is a good material and it has good properties, but we have to use it in the correct way. The impact of the concrete construction sector is quite high. When you look, for example, at the share in Vienna of construction materials, what we have in the building stock now, then mineral-based materials, where we count concrete to, have over 70%, so it's quite high. And you already introduced numbers from all construction materials worldwide, 60% are concrete, so the impact is quite high. So to think about how we can make this sector more sustainable is, I would say, it's one of the biggest challenges of this century. Because of the big amount what we use nowadays. Which levers do we have? Basically, the European Cement Association speaks of a 5C approach, and I think you mentioned a few of them. It's the clinker, the process emissions, and also the used fuel for the production. It's cement types and concrete mixtures. It's electric current and transport. It's carbonation. And it's CO2 capture and storage. From my point of view, we have to be a bit careful, because this 5C approach contains basic physical processes like carbonation. It's physics. So it's like that when we produce cement, then we have process-related emissions. It's chemistry. And within the usage of the concrete, and when you break it up again, this is absorbed. It's a chemical process, and I would not count it to an approach to consider that in a calculation, because it is like it is. And in addition, the 5C approach refers to additional technology to avoid CO2, and there, from my point of view, it's also maybe not the right direction, because to optimize processes, it's a bit regarding machine engineering, and I would see it as a basic need to do that, to optimize it as far as you can, but it's not a basic approach to do that. And yes, so I basically would split it up in one side on process optimizations, and I would say it's the task of the industry. So it's an important part. And the second part is the interaction of material, structure, and production of building components. And that's the tasks of us as material scientists and civil engineers. And from my point of view, there is no special weighting, because we are in front of a really big challenge to reduce the amount of materials what we need, and also to reduce the amount of emissions what we pollute. And so we have to work on all possible screws we have. So I would not wait it. When you look at the material, then you can focus on the reduction of emissions in that. And that's, from my point of view, the cement and the concrete mixtures. You can use concrete mixtures with a lower amount of cement. And we also have to search for alternatives, how we can bind mineral-based materials, because, as you heard, the cement production per se has a chemical process in it where we pollute CO2, and I think there are alternatives, but and there is already research on that. But from my point of view, we have to push that forward in a much more ambitious way. I would say it like that. And One further thing in the material is that we have to establish a real circular economy, because everybody's speaking of recycling, and it's a basic thing what we learned from nature, because nature has natural cycles, and they were there before we as humans lived on Earth, but nowadays we're developing things which hardly can implement it in the real recycling process. So we have lots of waste. We have lots of combined materials which we are not able to split up. And often when we speak of recycling, especially in the concrete industry, it's some kind like downcycling. If you use it as gravel afterwards for the production of a street, then I think it's possible to have a real circle, because nature does it, and we have to push forward strategies to establish a real circular economy. And that's, I think, the biggest topic regarding the material. When you think about the structure, then we can focus on structural optimization. And there in concrete construction, we have a quite big issue, because in former times, we had not that much material, and we focused on structural optimization because material was expensive and human labor was cheap. And now, within the industrialization, it changed. And we are now in front of that human labor is expensive, and we're not looking anymore at using the materials in the most efficient way. And there's really big potential in concrete construction for structural optimization. Yes, and when you think about the production, then there is a big potential to optimize the processes, how building components are built, for example, in a precast company or on construction site.
Mm-hmm. Yeah. So if I can summarize about the possibilities of the screws, you mentioned the material level and then the structure and as well the production level. And I think I would go back to the 5C approach you mentioned in the beginning. There's also, I think the last C is about recarbonation, which stands for CO2, which was emitted during the cement production is then reabsorbed by the concrete. What do you think about this screw? Would you say it is effective? Would you say it's more like a completion of the 5Cs, or how much CO2 can actually be reabsorbed?
Yeah, basically, we have the chemical process, and it goes the other way around too. So the process emissions, what we have in the beginning, they are absorbed again during the lifetime of the concrete, and it's a chemical process, and it works like that. There are also other strategies currently within research, and it's to actively put CO2 in concrete to store it for a longer time. It can be a possibility, but from my point of view, it's a try to do it in an indirect way. More a fan of that we are really confronted with things and we search for a direct solution. So for me, it's an indirect way to avoid a bit of the CO2, but it's not really working at the problem. That's my point of view.
Yeah, I also think that all the concrete structures would need to be crushed. So this is also a very energy intense process. So it is a screw, but a lot of screws have to be turned, as already mentioned. If we were now looking at all these environmental impacts of concrete and cement, maybe a crucial question, or in German we would say Gretchenfrage, pops up in the head of our listeners. So one could ask, so if concrete goes along with such high emissions, should we use concrete longer at all? Or should we maybe switch to maybe timber instead? What would you answer to them? And does concrete have an image problem?
I think it's a good question. From my point of view, concrete has an image problem. And as I said in the beginning, I think it's a good material, but we have to further develop it because we have some problems with the emissions, and we discussed that before. So I would say concrete, as it is now, is not the material for the future. in that way as we use it now, and then in that way how it is produced now. But per se, the idea of binding mineral-based things is good, and it has its advantages. From my point of view, the main thing is how we develop this sector into the future. I think we need it. I think it's a good material. We have good properties. But the main question is how it looks in future. And unfortunately, the construction industry is really conservative and not open for new things. Although we would have good strategies, from my point of view, we should work on the development. So, as I said, circular economy, maybe alternative binders, and also the structure and the production. And if we push that forward, concrete has a good future, but in another way. And we have to work on that the people who are in the building industry, and also the people who are ordering buildings, have more thought about that, what they order and what they want. So to really build in a sustainable way and to order the correct things, because if you have the money, you have the choice what you want to build. And currently everything is going about the profit. And I think it's one of the biggest things of society that we have to unlock the direct connection between the use of material and our further development, because it was like that in the past and it is still like that. And so there should be a new generation where these two things, material use and further development of society, are unlocked.
Mm-hmm. I want to put this further, as you said, that maybe concrete is or is not the construction material of the future. Because recently I got to know a project which has 4 numbers in its name. It's called 2226. It's in Lustenau, Austria, and the 4 numbers stand for the minimum and the maximum temperature within this building. So it should always be between 22 and 26 degrees. And what is very interesting for me is that this project does not have any installations regarding heating, cooling, or air conditioning in it. The outer walls are very massive. They are around 40 centimeters of brick wall, and then again for static reasons, and then again 40 centimeters just for isolating reasons. And for me, this project was very interesting, and I was asking myself whether rethinking in the building sector is necessary to tackle the global climate crisis. And I want to ask you if you also think that we need to think outside of the box, and if you maybe also would have some examples to outline your answer, this would be very great.
We definitely have to think outside the box. And when you talk about this building, it's interesting. What I learned, I made a comparison regarding a building and the further development. And it was quite interesting because I learned of this life cycle assessment of different embodiments of the building, that when you use bricks, there you have an interesting comparison to concrete, because the production of bricks is quite intense of energy because you need it for burning. And it's interesting because when you produce concrete, you only have to produce the cement where you need lots of energy, and it's a comparable smart amount. And when you produce the brick, then per se the process regarding one unit, for example 1 kilogram, is not that material intense, but you have to burn the whole brick. So maybe this building could also be built with concrete, and in the end having a better environmental footprint than the bricks. But the rethinking of the construction sector in the direction of using less energy is required, I would say, but we always have to compare how much energy and material we need for the production of the building, and how much material and energy do we need for the use and the recycling at the end. So the building you speak about, I don't know it in detail, but it sounds interesting, but it sounds also that we need quite a lot of material and energy for the production, and then you have not that much energy anymore in the use, and it has to be balanced. we did a comparison. I had the possibilities to supervise a master thesis, and there we compared a building within the whole life cycle in different areas of the world. And the outcome was quite interesting because we considered the production and the use, that the thing of the future will be cooling. And also it was really interesting that there is some kind like a break-even point. So when you use too much material for the construction phase, then you can't, I would say that then you would have to use it really for a long time to have a better environmental footprint in the end. So we were about between lowest energy standard buildings and passive house buildings. And if you make even better ones, then you would have to use it between 75 and 100 years that you have a better performance. And you always have to level that. And that's why we need to do a life cycle assessment and evaluate the environmental footprint over the whole life cycle to really be able to evaluate what is the better version.
Yeah, thank you. I think that's very interesting. When you say comparing the environmental footprint of buildings, like if I think about the daily grind with my friends and relatives, I often have a discussion whether, for example, glass or plastic bottles are the more sustainable choice. Often the first intuition would be that glass bottles are more sustainable, but on the other hand, they are heavier, so this is related to higher transport emissions. Furthermore, the production is probably more energy intense. So I think it's often not very obvious or trivial, as you said. And would you say that if you do a sustainability assessment of a structure, does it happen frequently to you that the outcome surprises you? Or could you say one could, like the first choice after engineering intuition would be, would lead into the right direction?
I would say sometimes it's surprising because we made, for example, comparisons between building materials, and there we saw that, for example, if you do a wood structure, we're also doing with my group research on wood constructions is a good one, but over the whole life cycle, it's often not the best choice for different purposes. And so it's better to do a real life cycle assessment because then you have the best combination. But I would be interested, what was the outcome between the comparison of the bottles? What's your choice now?
The outcome in our group was that I'm pro reusable plastic bottles, and the others also, and some are not sure if they prefer to drink from glass bottles. They also had they considered social aspects and they didn't prefer to drink out of plastic bottles, which also might be important in a case, but we didn't go into detail on that.
Okay. Did you consider steel bottles made from stainless steel?
No, actually not. So we should bring it up also on the analysis. Thank you very much. I also think that life cycle assessment is a very powerful tool to get more insight into the environmental impact of structures or materials. And I think it's also quite easy. One can look up environmental product declarations online and then get a feeling about the CO2 emissions per kilogram of a product. So actually everyone has the chance to do a first estimation or comparison on his or her own. I now want to move on to a slightly different topic. I know that you offer lectures and publish papers about the topic of automation and digitalization of construction processes. And I would be interested in how would you see the interplay between digitalization and automation and concrete sustainability?
I basically see digitization and automation as a tool that can support sustainable building construction. So we talked before about the possible approaches. For example, when you do a structural optimization, then the geometry ends often in a really complicated embodiment. And for example, digitization can be a tool to realize this kind of structures in a more efficient way. And basically, I would split it up in the different areas where you can use it. And for example, when you think about the design, then you can use digitization for structural optimization. For example, you can do an algorithm-based choice of a material, for example, maybe with reduced cement of amount, etc. And you can also include the environmental impact within an optimization, and that can be done based, as I said, on algorithms. And then when you look at construction, then we can look at, for example, prefabrication. We're currently doing a project in this area where we try to use robots for the automation process. And you can also think about on-site production, for example, when you use autonomous machines or something like that, or a crane which works on its own. But basically, it's often said like that the robots replace people, and then we have a problem to not have enough work. I have a different opinion, because I think it's required further development of society. Because when you look, for example, here in the industrialized countries, like we live here in Austria, then we have the problems that we have a lack of craftsmen. I use the word craftsman because it's often said that we have a lack of skilled workers, but that's not right. We have enough people who want to work, and people also in Austria are increasing the amount of people. So it's not the lack of skilled workers, and the people have skills, but the skills are a bit different to the skills what people had 20, 30, 50 years ago. And we are going more in the direction of digitization, and I would say it's not replacing jobs, but the jobs are different. And automation can be a good development also when you think about hard work, because when you work on construction site or in a precast company, it's quite hard work. And if you change this job, for example, to the programming of a robot or the supervision of a robot, then it's different and it's not that hard anymore. It's also about equal opportunity measures that everybody can do this. So I think it's a need that we go further in this direction, because otherwise we would go back in our development, and I think it's not possible in the evolution to go back.
I think there's a very nice words also about kind of one could say social sustainability of digitization, automation. When we're now talking about manufacturing methods, I think a lot of new and often fancy trends pop up, such as 3D concrete printing. What do you think about such new trends? Would you say that one should stay open-minded? Can they have the potential to revolutionize the concrete construction sector? Maybe with 3D concrete printing, one could say that we can put the material only where it is needed. What is your opinion?
Basically, I think we always have to be open-minded, because otherwise it's not possible to come further within our thinking. Regarding automation, I believe in that. I'm not absolutely sure about the direction. 3D concrete printing is a possibility, and I think it has its applications. From my point of view now, and what we learned within our experiments is that to lower the environmental impact, for example, by structural optimization, and to use this technology to produce these structures is for me a bit too far in the future. I think we have other possibilities with automation, what we can realize earlier. And I'm not sure if it will be a technology for the broad application. From my point of view, maybe it will stay in a niche. And I believe a bit in automating processes like doing the formwork and casting, because then you have the big screw of reducing the impact by, for example, the mixture. You can also reduce that with the process, and the scaling up, I think it's better possible. But I think it's important to do research on that and to learn more about it, because then you learn if there, for example, are applications where we can reduce the environmental impact over the whole life cycle of a, for example, beam or another building component.
Mm-hmm. Yeah, when I think about 3D concrete printing, I often think about some pots. So for flowers, for example, I hardly ever saw any structural constructed building components out there, but I'm very curious about the future. When you were talking about automation and digitalization, they also mentioned that you offer some lectures. How do you actually convey to the students here at the University of Natural Resources and Life Sciences in Vienna the urgency for resource-efficient structural engineering and, on the other hand, the necessary skills? So could you give us some insight here and what can the students do here?
At first, I'm really glad that I can do my research and teaching here at BOKU Vienna, because it's the University for Sustainability in Austria, and I think it's also in front worldwide within the leading universities, because we have, for example, the whole process chain regarding wood construction, and we look at sustainability from different dimensions, and that's the great thing, the diversity at the university. Basically, I try to teach the students to be aware of what do we have to do in the future. Knowledge is, from my point of view, the only key for a further transformation to realize the research topics and the topics what we discussed before. And it's the only possibility to engage a thinking regarding in acting in a more sustainable way, because how somebody should do it without knowing it. So for me, it's impossible that the students have a big picture and that they have the big view, and they're also able to do detailed optimization, for example, regarding a building component, and also the evaluation to do the life cycle assessment if the version is better than the other ones. So I think the awareness to support the awareness in early state and to deliver methods and tools to contribute to further development that's necessary within teaching. And therefore, I think that this topic, teaching students, has highest priority. For example, what we have at BOKU here is a new doctoral school. It's called Build Nature, and there we are dealing with ways how we can build in a sustainable way, and also how we can develop real circles in building construction.
If I can take away one key message, then you told us that the education of the younger generation is definitely important to educate future civil engineers to tackle the climate crisis. Could you give us an example of one of the last projects the students had to build or had to evaluate?
Yes, I can give an example. What we had a few years ago was, for example, a tiny house. Basically, you can discuss about that if it's a good way to do a tiny house, because you have a big surface for a small volume. What's not really good in building construction. But what they did, they had really nice ideas, and in the end, they compared how they can do it in the most efficient way, and they did the design and also the evaluation. Yes, or within the last year, they had to develop a module for a multi-story building, and one module where you can live in, and it should be able to be assembled more often. And that's an example. And also here, they developed the design, they made the structure, and then there was also the life cycle assessment. Or another project, what we did in the near past was that to make a wagon, it can be pulled by a car from an old building construction made of wood. We tried to recycle the wood and use it again as building component. So that's also one of the examples. And yes, we have quite a lot of master theses and also PhD theses where the people are working in the area of sustainable building construction in concrete. And there we have the topics what we discussed before: structural optimization, and also a bit thinking about replacement of cement and circular economy.
Yeah, unfortunately, during my studies, I never had the chance to actively participate in experiments or to touch the material. And I think it's very good, or I like it a lot that you offer lectures where the students can actively participate in the process and be part of the pre-processing and then the fabrication, also the post-processing, which is very nice. I would like to continue to some research topics where I would like to know a bit more. The first one would be high-performance materials. I think high-performance materials comprise, for example, ultra-high performance concrete with a very high compressive strength, and also maybe carbon reinforcement. So what is your opinion about it? Did you do some research? Would it be a sustainable alternative to conventional concrete? What do you think?
Thank you for the question. Did quite a lot of research using high performance materials, mainly focusing on non-metallic reinforcement and different embodiments, for example, made out of a combination in carbon fibers and epoxy resin, or also regarding glass fibers combined with epoxy resin and other resins, and also in different embodiments in form of textile reinforcement and rods. And on the other side, also on ultra high performance concrete. And what I learned during the last time is also what we discussed a bit before, is that we really have to evaluate if what is the environmental footprint regarding one unit, for example, 1 kilogram, what is the performance of the material, and what do we build with it, and are we able to utilize the full potential of the material? Because what we learned when using ultra high performance concrete is that it's a good material, it has a really high performance, and if you have an application where you're able to fully utilize the potential, then it's a good thing. But accompanied with that, things are coming up with the accuracy of the production of the building components, because then, for example, if you dimensioned a structure which is really thin, then of course the deviation of a thickness have a big influence. That's the main thing. And also it's quite hard to do a structural optimization to fully utilize ultra high performance concrete, because if you have a concrete thickness between 20 and 30 millimeters, then it's complicated in realization. So from my point of view, the important thing is to use it where you can use the full potential. Otherwise, it's not the right way. So to generalize, to use only high performance materials, that's not the correct thing to do. You have to look what is the requirement and where you can use it. So high performance materials have their potential, but not for every use, I would say. And also when you look at non-metallic reinforcement, there I see a bit still the problem of recycling. The really great thing is that there is no corrosion, and that the potential can be that you increase, for example, when you do a bridge, where you have salt and something like that you can increase the lifetime, and the lifetime is one of the biggest levers regarding the environmental impact, because if you are able to increase the service life for 20-30%, then the environmental footprint can be reduced a lot. So also here, I would say it depends where you use the material, but they can be good things, but not everywhere.
So if I can summarize, one can say that high performance materials, there's no general yes or no, and everyone has to make the decision on an individual building or construction and check whether the environmental impact is lower in comparison to a conventional structure. Another topic I think is very interesting is, can kind of like bridging the gap between two, I would not say friends. What can you say about or tell us about your research on wood, concrete, composite structures?
That's really interesting because we started to do research on that. Basically, it is like that using wood is a good thing, and I don't see wood in the opposite of concrete. It's another material. It's a great material, but we have a limited availability. So we have to think about where we can use it and how we can. I would say how we can increase the buildings that we can build with wood. And for example, for a slab, you have the possibility to do it, for example, from CLT, but then you need quite a high thickness. You have maybe problems with vibrations. And so it's a quite good thing to combine it with concrete, because then you can use the concrete in the compression zone, and that's what it's a good, has a high compressive strength, and you can use the wood in the tensile zone. And I think it's a good combination. Where we have to work on is the recyclability of these structures, and also how to further improve the structural performance if you can, for example, reduce the material amount by structural optimization. But also here is the connection to the things discussed before that also applies for this kind of structures. And what's also very interesting for me is the connection between the concrete and the wood plate, and we're currently doing things with mechanical connectors and mechanical connections by, for example, milling a pocket or a notch inside the wood plate and then having a connection. And also we're trying a bit regarding gluing the things. Gluing is not that good often when you look in this direction, but in the end, there could be a good recyclability, but that's topics of the future.
Yeah, I think it's a very interesting approach to bring those two materials together and get the most out of both materials. When I think about wood, concrete, composite structures, and I think about the economy, I see a lot of experts on either concrete or wood. And I was asking myself whether it is very challenging to bring these companies together to create such structures. Do you have any experiences on that?
It is indeed a bit complicated because it's a completely different way of working. Because when you look in a workshop where people produce things out of wood, it's completely different, also smelling different than looking in a workshop where you produce concrete parts. And also in reality, I think they are a bit the opposite, because every branch is arguing that they have advantages compared to the others, but in the end it's like that both materials have their advantages. And as I said, you have to use it in the correct way. I made the experience within our cooperation we have quite a lot of cooperations with companies. We're working close together with companies, that for them it's quite hard to work together. But in the end, I think we have the big need of further developments of the construction industry, and that cannot be the problem of the future. I think if we have disruptive further developments, then this will be the smallest problem. If we go more in the direction of prefabrication, then it can also be easy if one part is delivered to the other company. I think there are solutions, but as I said, building companies are conservative, but they will find a way.
I would also say they are very conservative, but I think, at least from my point of view, I would say the last few years, one can feel that they are catching up the innovative spirit. I now want to throw in something else. My civil engineering friends often say or feel like that the topic of sustainability is very specific to our present time. what do you think about the interaction between the topic of concrete sustainability, the present and the past? Could we somehow say that we now have the age of sustainability?
Basically, not perfectly going along with that, because I think sustainability itself is one of the oldest things what we have, because when you look in the past, there was always the necessity to use the things that you take from nature, the resources, in the most efficient way, and to give something back. I have the feeling that within the industrialization, and especially within the last 20-30 years, we unlearned sustainability, and it was a bit that everything was going up, that the prosperity is increasing, and that led to the problem that people don't know anymore how to use the things in the most efficient way. Also, when you look back to the big world wars, then people had only a certain amount of material, and you find lots of pictures where they reuse the materials, and they had not that much. And now we have the problem that we have too much, and that we think that we redevelop the thing of sustainability, but in the end I think we forgot it and we have to do it again. And it's from this perspective quite interesting for me. But as we currently use too much materials, a lot too much materials, I think it's one of the topics of the 21st century.
Yeah, it's very funny because as my friends say, they feel like it's a topic of our time. I would have also said that a few years ago. But last year I had the chance to participate in the FIB Symposium on Conceptual Design. It was in Switzerland, and it took place at a reconverted industrial area. And I was very fascinated by the slender concrete truss structures there. And I think they were built around 1900. And without further looking at the details, one could say that this truss structure looked very sustainable with a minimal use of material. And so if I think about modern construction of industry halls, I always imagine those massive concrete beams. So there I was asking myself if I actually only have to learn from the past to create such nice, slender and resource-efficient structures. So now some words about the future. What is your personal vision about the future, like construction-wise or in general? I think one can see a lot of positive signs. For example, here in Austria in summer, we have the implementation of the planned CO2 pricing. And there's also a new cement type currently being developed with a reduced clinker share. If you would look into the future, what would you see?
I see that we have to develop buildings with minimal and environmental impact over the whole life cycle, and we have to develop a real circular economy. I think that's the biggest topics. Don't want to use them as shiny words. We have to really do that, and that's for me the future of building construction.
Are there some kind of basic laws you could apply or you could recommend civil engineers or students which they should make in the future, or to push structural sustainability forward in the best possible way, if you would have to give one advice?
Yes, to evaluate which version is the best one. I think they have the basic tools for the structural design, and to know about the properties of materials. But one of the additional main tools should be life cycle assessment, to evaluate which direction is the best one, and also to think about the lifetime. That's the biggest things. And the most important thing is to discuss with the peoples using the buildings what they really need, because we have the problem that we are building bigger and we need more material, but in the end often the space is not required for the things what we needed. And so to basically think about the real needs, that's one big thing of the future.
Yeah, thank you very much. I think those are very nice words to come to an end with our podcast. Thank you very much for your time and being on this podcast. and allowing us some insight into your research, teaching, and practice.
Thank you for the invitation, and I wish you all the best.
Thank you. Now I have information for our listeners. I will link the infos about the profile of Professor Benjamin Kromoser, as well as address projects or contents at the website of the FIB podcast series. The team of Professor Benjamin Kromoser also has an Instagram account for science communication called Kromoser Research Group, which will be linked there. If you have any special wishes for upcoming podcasts, for example, who should be my next guest or which topics to be addressed, send me an email. You will find my contact details also on the FIB Young Members Group podcast website. Thank you for listening, and until next time.